All right, so this guy throws this brick from the top of a building at an angle of 25 degrees to the horizontal with an initial speed of 15 meters per second. Whenever you're given data that's not perfectly x and not perfectly y, you know, here's the x, here's the y. Is this 15 meter per second? Is that perfectly x? Mm-mm. Is it perfectly y? Mm-mm. So what do we have to do to it? Break it into, what's the word? Components. You got to break it into its x and y components. So here we have, I'm going to do this in red. This represents the x component of the 15 meter per second. This represents the y component of the 15 meter per second. How do we solve for the x component and the y component? With trig, sine and cosine. All right, so I'm not going to show that. Well, here, it's early in this chapter, so I'll show it. This Vx is going to be cosine 25 times 15. That just comes from the definition of cosine. Vy is going to be sine 25 times 15. Okay, so this comes out as, so Vx comes out as 13.595. Vy comes out as 6.339. Now, if the brick is in flight for 3 seconds, how tall is the building? So really, you know, we're given the initial velocity of the brick and the time in the air. And the question is, what is the height of the building? So this problem could be solved by breaking it into multiple steps. And I've seen, you know, over the years of doing this problem, you know, I've seen kids do this. What they do is they find the time to go to here, and then, you know, subtracting that from 3 seconds, then they have the time from here to the ground, and then what else? So then you got to figure out the maximum height. I don't know, you break it into all these parts to figure out the height of the building. It's doable. You can do it that way. But if you realize one thing, you can solve this in one calculation. What's the one thing you have to realize? In the kinematic equations, in the 4 motion equations, what is x? It's a displacement. And what does displacement care about? Starting point and ending point. So where does the brick start? Here, let me erase this. The brick starts where? At the top of the building. Starts right here. Where does the brick end? Vertically, right? We're separating the x from the y. Vertically, where does the brick end? Down here, right? The height of the building is the vertical displacement, right? This right here is the vertical displacement. We're separating the x from the y. So it's not like this. It's not like, oh, that's the displacement. It's not that, because we're separating x from y. The vertical displacement is that, which is the height of the building. Does that make sense? So basically, let's call h, we'll call it y. Y equals the height. And by the way, is our y, when we solve for this y, is it going to come out plus or minus? It's going to come out minus, because is the brick going up or is the brick going down? It's going down. So y is going to come out negative, but it'll give us the height. So here's how I think this is the easiest way to do it. Using the first motion equation, y equals 1/2 g t squared plus vy initial t. So y is 1/2, g is negative 9.8, time in the air is 3 seconds, vy initial, what's vy initial? It's right here, 6.339, and then time in the air is 3 seconds. All right, this gives an answer of negative 25.1. So what's the height of the building? 25.1 meters. That's the height right here. The height of the building is 25.1 meters.